Hello, and thank you for joining us. My name is Misha Goffstein. I'm a founder and chief security officer of AlertLogic. AlertLogic is a company that spends a lot of its time securing cloud environments. We have a lot of experience with cloud deployments and have a lot to share in terms of surviving a breach in cloud environments. Have had a lot of customers that have gone through scenarios that have taught us a lot of important lessons. Joining me here is Sven Skog. Sven, you want to introduce yourself?
Yeah, Sven Skog. Most people need that pronounced a couple of times. I'm the chief security guy at Monotype Imaging. We're a textography and image sharing service. We're heavily partnered with AlertLogic for this and other services. Misha's name and mine are both worth about 144 points on our triple word score. So.
Can we advance?
Absolutely.
So what we're going to cover today are two aspects of a breach, and what we wanted to do was break up the story into what you should consider doing before the breach and steps you should take in order to make sure that you're prepared, but also cover what should happen after a breach. This is one of the most commonly misunderstood topics. A lot of times people wait until they're broken into to start responding, and it's not just a matter of having an incident response policy, and it's not just a matter of having a plan, it's a matter of having a plan that's actually tailored to your environment. And in fact, a lot of how cloud environments operate should change the game for you, right? Should change the way that you construct your post-breach incident response plan, right? So we're going to go through those two topics in a tag team fashion. I have a few points that I want to make, and then Sven's going to take us through some of the deeper dives into how he actually does this as a practitioner. So we wanted to start this conversation with just a very high-level view into where we are now. I probably should ask up front, how many people in the audience have security as their number one job and a primary responsibility? So that's about 25%. So those of you in the security jobs, you've heard of the Verizon Breach Report, you've seen it before. This is probably one of the most useful research projects that's been around for over a decade at this point. We read it religiously every year. Something very interesting happened in this latest report. For a long time, we kind of viewed the Verizon Breach Report as something that didn't really reflect reality as we saw it. Most of our deployments, we have about 4,000 customers there in a lot of data centers and cloud environments. We see a huge number of web attacks out there, and that's never been the case when you look at the overall industry trends. It is starting to change, however. If you look at the latest figures from the breach report, all of a sudden there's been a dramatic increase in the attribution of the most common attacks being attributed to web applications. This is very consistent with the world as we've always seen it. Pretty radical step up, right? We're talking about less than 10% in 2015 to nearly 40%, which is, again, if you just look at web incidents that flow through our SOC, that's about the number, right? The number of web incidents we see on a quarterly basis hovers right around 40% mark. And in general, I think that's an overall trend. I think more and more applications are leaving their corporate data centers. I think as the applications get rewritten, a lot of times they get rewritten with web technologies, and this has been going on for quite a long time. Obviously, the attack trends are starting to catch up to that. And for that reason, one of the things we strongly advocate is making sure that you have the right perspective on exactly what it is you're trying to protect. And one of the things that we're adamant about is that your playbook for how you protect your cloud environment, and especially the web application and database workloads that may run in these cloud environments, should be substantially different than places like point-of-sale networks, right? This is the classic target breach, right, where the point of entry was actually point-of-sale network, right? The strategies you're going to put in place for those two application types are going to be radically different, and yet that's not necessarily the way that everybody in security always approaches things. So one of the things that we strongly advocate is making sure you understand what are your number 1, 2, and 3 kind of attack vectors, right? If somebody's going to come after you, what are the most common points of vulnerability? And this goes beyond just doing an annual pen test. It's about understanding what are the most critical applications, what are the potential flaws in them, and how do you construct a set of defenses that actually fits that environment, right?
Perfect segue into a day in the life of a threat landscape. The Monotype Corporation, like many of you out there, is a hybrid environment existing between on-premise traditional and more web-based AWS service. We're maybe 50-50, perhaps 40-60 now as we do the web transition. Far and away, the most prevalent attack that we see every hour of every day of the year are brute force SSH attacks, which are not very useful to kind of ground clutter, except for a point that I'll bring up later in the presentation. The most ubiquitous attack that we see every day that does concern me and people like me is SQL injection. Many of you who raised your hands are familiar with this, the notion of injecting executable code or statements to be used in other than a literal HTTP URI sense. And what I'm starting to see this last 18 months is this cascade two-stage recon of a mathematical function floor around this floating point number down to the 1.0, the 0.0 number. Rand, give me a clock-generated seeded random number between 0 and 1. These, of course, have no meaning, right? We're selling fonts and images. There's no way that mathematical functions have any purpose in the URI, except as a preliminary recon indicator saying, let's see if the server will correctly bounce back a 404. Sorry, I don't know what that is. I can't evaluate that. Or if it's feeding back some garbage. Yeah, and by the way, 2 times 2 equals 4. Thanks for sending that in the URI. At which time we'll see more of the traditional SQL select, SQL concat, SQL drop table, select table, modify. Many of the people in this room are familiar with the Elasticsearch structure, which is a hash-based structure using Lucene indexes and things that make non-computer science people bleed from the eyes. What we're starting to see now are, as you know, Elasticsearch is not well protected. It's mostly clear text in its retrieval and interface, primarily for ease of retrieval and speed of use. So we're seeing some search equal random, some match all Java methods that I see out of the Far East that oddly have vulgar names, right? I see that attack over and over again every day. And we have, like many companies, we have a couple of WordPress blogs that detail our innovation and our more forward-leaning R&D projects. We see the typical WP admin and the WordPress plugin attacks like some of you do. I also see some interesting credential reharvesting in conjunction with the SSH brute force, which I'll get back to as we talk about actually correlating different attacks at different phases.
Sven, let's stay on the slide. I have a couple of more points to add to that. Sven mentioned WordPress. A lot of people will be surprised, but while I agree with Sven, SQL injection is one of the #1 attack vectors that we see in our Security Operations Center. But WordPress is probably #1 application that's targeted. And the reason for that is because I've been surprised by how large WordPress has gotten. I think by the latest research shows that WordPress is about 25% of all websites on the internet, which is, that's a pretty dramatic number. And I don't think all of those are personal blogs. I certainly don't think these are all not unimportant sites. There's a lot of companies out there that use WordPress as a platform they build on. For example, if you go to the Tribune companies and you leave a comment for somebody, usually it's the WordPress application that's underpinning it. Now, obviously, it's an open source code base. There's a lot of contributors to it. Historically, it's been fruitful for attackers, right? There's more than a few vulnerabilities in it. But we're also seeing some really interesting trends emerge with SQL injection. We see a lot of these, a lot of this data with our customers. The most interesting things we found, and we've applied a number of machine learning techniques to this, we've recently realized that when you really break apart what SQL injection attempts consist of, you realize that there is really no such thing as a SQL injection attack. SQL injection is really a method, but what you can execute using that method is a pretty wide diversity of steps in a kill chain. So we see SQL injection used for initial recon as you enumerate table structure. Eventually we see kind of full attack progression all the way to exfiltration of data. These are zero persistence threats. For example, no files are changed, no memory gets injected, right? There is really nothing to see on a host, right? Nobody ever injects malicious code into a host. Data is stolen 100% through SQL injection. And the most aggressive cases of this we have found have been kind of multiple months in the making, literally attack progression where each stage of the attack happens from different address space around the world. We do find commonality between them. We can put them together into an attack that we know is actually related to each other. But it's really interesting where if you do have a SQL application and it has SQL injection flaws, one of the easiest ways to kind of fly under the radar is to use those flaws without ever being detected. That's a very, because the amount of noise SQL injection generates both with SIMs and with WAFs is pretty immense. This is a pretty big challenge for a lot of the defenders out there.
No, I think that's an excellent endpoint. If you don't see the SQL attack in flight, you're probably not going to see it at all.
So one of the things that we're seeing with a lot of the deployments that we come across is that and it really splits into two different categories, right? We have a lot of people that we see do forklift upgrades, right? And they literally move from their on-prem data center, where it's a fairly large environment, maybe segmented by a firewall, but really there's little segmentation, and it kind of moves wholesale into a cloud environment. And the network topology almost exactly replicates what they've always had in their on-prem environment. Very quickly, though, a lot of these companies realize, the marginal cost of spinning up a VPC is zero, right? It doesn't cost that much to isolate further. So what we're seeing is that companies that have a lot of web applications and have a lot of web applications for different needs, I mean, sometimes these range, anywhere from a couple of thousand to 20,000, right? The best practice is to really build a VPC for each one of them, and very similar to the way you want to limit blast radius for your availability, you also want to limit the blast radius for your breaches, right? If somebody breaks into any one of those applications, one of the things that's finally possible, primarily because of the tools that we have in cloud environments, is the ability to make sure that breach does not go beyond the walls of that application. And that's a pretty big deal, right? Imagine an environment where you have hundreds or thousands of applications. Breaking into a WordPress installation shouldn't be a reason why you have the keys to the rest of it, right? And that's one of the most important things to get right. I think the lesson to take away here is that you got to get involved early, and you have to make sure you plan for this, right? Because if you as a security practitioner don't have this conversation with the cloud team, and you're not on the same page about the way that this architecture should work, you're probably leaving a lot of cloud benefits on the table, right? One of the essential steps towards resiliency is making sure that you get the architecture right from day one. It will dramatically change your outcome in the future.
Excellent point for a springboard. It doesn't cost that much to isolate further, right? I think that's probably the one-line distillation. Monotype, like many of you, currently has more than 24 Amazon accounts. And I'm going to just put it out there and say, in this day and age where AWS has 10 plus geographic regions and auto-scaling templates, seamless replication between zones, dual to quadruple times as many availability zones as geographic regions, there's no reason for any of you to be putting all of your valuable assets into one dirty, unwashed, unsafe barnyard, right? Split that up to the degree that you possibly can, app by app, dev by staging by production, QA testing and UA testing if those are something that you do in your enterprise. Keep the root account sacred. There's no reason that the super user credential, the IAM key associated with the entire account needs to be used. Personally, we keep this in a Gemalto hardware token. We actually lock it in our server cabinet along with the server keys. And this is used maybe 3 or 4 times a year, right? We have delegated super admins and then sub roles that receive fewer permissions and sub roles that are just day-to-day log in and do this specific function or this service account. Keep those permissions sacred and don't mess with those every day. Inheritance is something that's taken off great guns this last couple of years. Define a minimal function account, then inherit with some greater permission, and then inherit that up to a super user who can then allocate and create additional user permissions at that same level. And use multi-factor wherever possible. We have a show of hands. Who's using multi-factor in their Amazon accounts right now? Great answer. Not nearly good enough, right? Go out and buy a few 695 hardware tokens. Go out and use a partner like RSA Secure ID via Okta Meta Directory, single sign-on. The Duo mobile push is an excellent solution in this space. There's lots and lots of players. Even a text message. The US NIST cryptographic standard is now saying don't use text SMS messages for one-time factors anymore. Even that is better than nothing. Even that is better than what about 48% of you in this room just showed me that you were using. So go multi-factor if at all possible. Do not share accounts. Do not share credentials to the fullest degree possible. If you have to, I'll talk about a way to do that later. And look at your queries once in a while. Do some not just layer 3 filtration, but go all the way up to layer 7. And look, your load balancer will do a very small amount of this by itself. Some of you have exposure to Amazon's CloudFront service, which will take the traditional ELB and put some security oversight on top of that. Many other competitors in this market who will sell you very nice WAF, WSM, web security modules, some of whom are in this room. No reason to stop there.
I did not ask him to say that.
Go with the old classics, a layer 3 ACL security group. I think Amazon's current rules are, what, 50 or 100 rules per security group, but you can layer and inherit security groups, so there's no reason not to go robust there if you need to. Even if you have, we keep coming back to WordPress and kicking it like a dead horse, but even if you have a blog server that you think is getting targeted by certain sections of the IP space or the geographic community, no reason that you can't put an HT access file on top of that and hard limit IP accesses, in which case you're no longer getting hacked by Asia Minor, Asia Major, you're now getting hacked by those same people who've gotten into rack space addresses, and less said about that, the better. Let's not forget that the final layer of defense here ought to be in your own app and business logic itself, right? I think that most of us are agreed that CAPTCHAs and reCAPTCHAs tend to pollute the user experience. They're ugly, they don't like them, we don't use those. However, if you're in a situation where you've got a simple log parser looking at your transactions for the last 60 seconds, 5 minutes, 10 minutes, and seeing, somebody tried this thing 10 times or 20 times in rapid succession, odds are good that's not an innocent human. And now I can maybe bandwidth throttle that bot. I can CAPTCHA challenge that bot and say, hey, show me this token before we move forward. Prove to me that you're somebody other than a malicious visitor. Yeah,
this reminds me of one of the incidents that we just looked at in our SOC, and this is one of the things that people don't often think about because it kind of slips through the cracks. It's not very sexy. This is a pretty boring, incident. We saw about 250 logins into an Apache Tomcat admin interface, and it's not clear why this interface was open to the outside world. That should never happen to begin with, but suffice it to say, you really can't block that kind of activity, right? That's not something you can block inline. Very low number of attack attempts, right? I mean, the usual brute force attack is measured in 5 to 10,000 at least. Usually, the dictionary files are pretty long. Saw successful login following those 250 attempts. That's exactly the kind of issue that Sven is talking about. It's not always clear how attackers know how to execute low and slow brute force attacks, but kind of collecting intelligence on you by looking at less important assets, right? And that's one of the reasons why you want to protect even things like blogs, right? If they figure out you as a user use a certain pattern to construct your passwords, the password file for that gets dramatically smaller. That's how you end up with a scenario where there's 250 login attempts and then a successful login. Nobody's that good at guessing without having some kind of intelligence up front. Right?
So actually, maybe it feels like we're demonizing WordPress here, which I don't mean to do, but be careful what you put in your company's public-facing image, right? If you're putting secret project names or too many of your staff names or maybe an intimation that so-and-so is related to so-and-so in this organization, that's all fodder for a future directed attack. And it's stealing the thunder for a couple of slides in the future, but what Misha and I have both seen are the WordPress blog information is used as an Outlook webmail server attack to harvest usernames, use it there. The email usernames that return as valid are returned back into the WordPress attack, and now I've got a much smaller space of dictionary attacks, right? Be cognizant of what you're putting out there for an attacker to use as a handhold.
So if you get your architectural principles right, and if you limit the blast radius, you're not quite done, and there's still more steps you have to take in order to make sure that you can actually survive a breach. If you've ever done incident response, this is the most classic scenario, right? For some reason, the first thing that people do when they experience an incident is yank everything offline, reinstall from backups, and this is an old world where there were still backups being used. Wipe out all evidence and essentially then call incident responders and ask what happened. If that's what you're going to end up doing, chances are nobody's ever going to be able to tell you what happened. In fact, collecting telemetry from both the cloud environment and your systems and applications is something you have to establish long before. If you don't know how to read those logs, a really good time to learn is before the breach, not during or after, right? What's really different and what really changed in the last 3 years is the availability of telemetry we've never had before, right? We've never been able to have nearly the level of visibility, and I'll give you an example of this, like you have with CloudTrail, for example. It should be a game changer for people with a SIM. It should be a game changer for anybody who's responsible for monitoring. But usually, security people are kind of blind to this, and they're still operating in the old world, looking primarily at system and application logs, maybe network logs. Whereas a lot of the most important data points are going to be in the native AWS telemetry itself, right? So we'll show you what an example of this looks like, and this is just one message that you can get out of CloudTrail, but there's a wealth of potential here, right? The three things that I really highlighted here is the username, the mode of access, right, and the user agent, right? And imagine what you can do with that kind of information. For example, in AWS, a lot of times users have a very persistent set of user agents that they use. They don't change all that often, right? If you have a console login, you typically use that console, you typically log into a console fairly frequently from a very similar device. Any change in that user agent should be indicative that something's going wrong. And this is one of the things that's very difficult for attackers to fake, right? It's not that attackers can't fake a user agent to make it look exactly like your user agent, but the amount of recon and intel they got to do in order to get that done is tremendous, and frankly, not all attackers are that good. There's a lot of people out there who give up, and if you kind of listen to the little clues that we get in news stories about how we attribute attacks in high-profile cases, a lot of times it's attackers being sloppy and revealing themselves in exactly these kind of situations, right? So mode of access, user agent, very important data points to collect out of CloudTrail. Now, is it useful just by itself? No, we're thinking about applying machine learning techniques to it, and I think anomaly detection would be, just basic statistical anomaly detection would be very effective with something like this, but you can tell quite a bit just from kind of the pattern you see from these 2 points, right?
So themes we're going to return to again and again. Familiarize yourself with what the new normal looks like on your network, your environment, your user access, and try to get some of this tier 0 ground clutter analysis out of the way such that it's being done reliably and daily whenever possible. I think those are 2 excellent points. Okay, I'm just going to say it. This is probably the most important thing in the presentation. If you walk away with nothing else, walk away with this, folks. If your information is not encyclopedically and comprehensively and reliably logged in 2 or more redundant separate places from moment 1 of your application's launch, as if it were preserved for a courtroom proceeding, you might as well not have it logged, right? Server local logs are subject to deletion, to corruption, to worse, to infiltration and manipulation such that either the attacker's traces were taken out of the log or maybe some false attribution was put into the log to implicate someone else. You need to be logging these in at least 2 places, and I'm going to say 3 is actually a best practice now. Syslog, authlog, audit log, the Unix heads in the audience are very familiar with what I'm talking about. The Microsoft unholy trinity of event system security viewers, very, very important. Don't just stop there. Your web servers themselves, your IIS, your Tomcat, your Apache, your Nginx, whatever else you may be using. And I'm going to say that in environments where you can syslog out your firewall to some third source, by all means, capture your firewall and your proxy logs as well. Access and errors, don't just collect what was accepted and what was denied, get both, even though the deny will be 10 or 100 times more voluminous than accept. Meta usage, this is really what Misha was talking about before. There's actually a higher level within the AWS environment, which is which users accessed which subcomponents at which privilege level at which time, right? User Misha may be accessed from this endpoint with this permission or invoke this API with this success or failure result. That stuff's pretty interesting to the degree that you can read it all. This may get overwhelming depending on the size of your enterprise. I choose to look here, I focus on API invocations, on new role creations, on permission edits, additions, deletions. Somebody made a new user, somebody gave an old user new permissions. That stuff is interesting to me. And then if you can afford it, go down to the next level. DHCP lease grants, switches, persistent point-to-point VPN tunnels, such as those used within VPCs. Last I checked, S3 and Glacier were at what? 4/10 of a penny per gig per month, 7/10 of a penny per gig per month. Don't worry about it, you can afford it, right? This isn't all that expensive. Keep 2 or more copies. One of them can be host local, one of them should be somewhere else, either within your local on-premise aggregation or perhaps in an S3 bucket for reasons described earlier. If you're not going to encrypt this, which is a best practice, at least put it in a key-controlled volume, or at least do some kind of cryptographic tamper-proofed hash saying, this is what the SHA stamp was the last time I looked at it, and now that I'm looking at it 6 months later, it's the same SHA stamp, and I can prove in court that I didn't delete, permute, or change the logs. For those of you who aren't crypto geeks, the MD5 hash and the SHA-1 hash have been broken for quite a while now. SHA-1 is quite shaky. It's got to be SHA-2, SHA-256, or stronger. And don't skimp here, right? Do this in day one. This is stuff that you're going to need not today, but 6 or 8 or 12 or 15 months down the road when you have some procedural forensic investigation that says, how long ago did somebody break into Amy Pascal's Sony email server? When did she know? When did her sysadmins know? This will come back to bite you. Event reconstruction. This means different things to different people. Minimally, you should be able to surf through your logs or have some third-party outsourced SOC look through your logs on a daily basis to get this, I don't want to get too Big Lebowski here, but this notion of a holistic cyber weather forecast, what the typical traffic of the day, the attacks of the day are, and whether that looks normal for that day or whether things have changed in the last 30 days, what that change might mean. Even just seeing typical flows like the last 3 requests came from this standard rack space provider, or the last 3 attacks came from Lithuania, those might be valuable. Timing, chronology is always important here. Frequency of attacks, is it just you being targeted or is it everybody within your Amazon site or your Amazon subnet? A real world example that I like to cite here is that I see a lot of SSH brute force attacks. I've mentioned those already. And I think those are from some 14-year-old kid in Estonia, some script kiddie who's got a few extra hours to do with his botnet. And that's okay, that's ground clutter that I'm not so worried about if they're just hammering my Amazon web servers every day, every day, every day. The minute that 14-year-old Estonian skitty hits my Amazon servers and then switches to my corporate OWA webmail server, then I'm fascinated, right? That's an evolution in traffic flow. That's my weather forecast shows that something behaviorally is different. It's Misha's point about the known user conduit, the known user agent, and the known user endpoint all over again. The minute that changes, I really want to pay attention to that. And that, to me, that's a tier 3, tier 4 escalation. That's something that we need to watch and realize what attribution is really going on here. Yours are not the only sources out there. Don't be afraid to Google for known patterns or known attacks. That floor and rand and concat stuff that I talked about, that's been out there for at least a year and a half. That's well-known patterned activity, and if you're getting hit by it, you're by no means alone. I think I've already babbled about WordPress, and I feel bad continuing to kick it in the ribs, but we are seeing credential cross-harvesting here. Find every single little bit of text that's interesting in the WordPress blog, use that in corporate SharePoint servers, corporate email servers, Amazon web servers, try to use first name, last name pairs, credential harvesting, some very creative attacks there that we inadvertently put some fodder out on the internet ourselves. An example of, if you want to go beyond logs, this is going to vary depending on your own capability. If you have your own Snort or SourceFire, or if you've partnered with a third-party appliance that actually go down to the packet level and do PCAPs or even NetFlow 5 tuples, source, destination, payload, you may be able to see some interesting things. In my case, we run a lot of e-commerce web servers that, because they're selling fonts and typography letters, will see text like the quick brown fox jumps over the lazy dog, which is okay. But if I start to see first name, last name, or if I start to see binary offsets, that may or may not be stack memory locations, or if I start to see 1 equal 1, 1 pipe 1, 1 minus 1 SQL injection conditions that mean this is always true, so run this loop each and every time. Don't ask me for authentication. Don't ask this program to check before it just runs the next command. That stuff's interesting, and I think you'll find that any reasonable third-party SOC, AlertLogic or SecureWorks or other, will immediately alert this as a telltale beaconing of an attack.
And going to packet level detail is really essential if you want to go beyond just kind of notional logging, and there's a reason why it's worth doing it. Most of the logs that we get out there are not stateful. It is difficult for us to understand what exactly is happening in each one of those transactions. Even when we see an attack reflected in one of the logs, for example, it's virtually impossible to know whether it's been successful or not without seeing the server response. And this is where things get surprising. You look at a typical web application firewall and you try to look for responses. They only log attempts, they don't show responses, right? So you can use it for filtering, but you can't use it for detection necessarily. Same thing with Apache logs, right? You would think that Apache logs give you everything you need in order to monitor web attacks. Not entirely so, because there is no responses included in those logs. The complexity and cost of having Apache log that would be pretty severe. So this is where you lose visibility unless you go to packet level detail. And it's one of those things that's, especially if you're in a real-time incident generation business, it's very difficult to do anything without being able to see the full packets. So what happens after the breach? The classic playbook is to cut the cord as soon as possible. We've already touched on this. This is probably the most natural reaction from anybody out there, and I think you see it in the movies, right? There's always somebody running towards a data center as if there's one plug that you can just pull and unplug the entire data center. I don't think it's always a good idea, and I think there's some reasons to have a game plan that doesn't always cut the cord as soon as possible, and we'll give you a couple of reasons why that might not be the case. Now, when I put the slide together, Richard Comey was not yet famous. The reason he's in this presentation is actually not because of the election, but before the election, if you can recall the Apple case, right, where this is a big deal, right? This is Department of Justice suing Apple to make sure that they could kind of install specialized malware on a phone in order to break into it. But why did the whole situation happen? And if Richard Comey can be blamed for anything, it's for being overly transparent. He very clearly explained, look, we made a mistake, right? The response, the immediate response post the San Bernardino shooting was too fast and we didn't think enough. And he wasn't clear exactly who did this, but it was somebody in the field who wasn't really used to dealing with forensics, right? So what they did was they mistakenly believed that if they changed the password to the iCloud account, they'll be able to recover all the data, which is the opposite of what's actually true, right? So they ended up locking themselves out of data they probably would have had easy access to if they just slowed down, brought the right people in, and took their time to do it. So there is a downside to moving too fast, right? And what we usually recommend is that you really have to, this is the famous jump to conclusions, Matt. Which movie is that from? That's from...
That's Office Space?
Office Space, right. I think you have to ask yourself, what do I really care about, right? What outcome am I looking for after a breach? And I think this is one of those scenarios you want to role play through before you get broken into. And this is where I recently got educated in kind of how the government does this. There's a guy that we know in common who used to work for MITRE, and the government stages a lot of cybersecurity war games where they practice certain scenarios. There is no reason why we shouldn't be doing that in corporate environments as well, and there is not one playbook, I think, that's consistent for everybody, right? Should you always respond quickly and recover as fast as possible? That really depends on the type of environment you run, and we'll give you an example where the trade-offs at least deserve to be thought about, right? Now, the downside of getting this wrong, right? Another FBI case, right? What happens if you recover fast but close out your ability to figure out whether or not the attackers were persistent and highly sophisticated and were coming after you not for the last couple of weeks, but maybe for the last couple of years, right? And they want your environment so badly that you missed a couple of years worth of fairly heavy attacks against you that may have been very stealthy and you didn't know about them. There's been a number of cases where because of inadequate visibility and inadequate forensics, in a lot of government networks, it's anyone's guess whether or not the attackers are gone or not, right? They've dug in so deeply that at this point, nobody has the confidence in these networks. And this is the downside of not having a game plan ahead of time and making sure that you think about the stuff before you get broken into, right?
I'm going to sidestep that whole Director Comey thing. But it does make me think of a Fulbright Air Force colonel with whom I worked for several years. Returning from his tour in Afghanistan, this colonel used to say that upon hearing gunfire in the forward operating base, he would intentionally he would fight his unconscious response to pick up the radio and say, what's happening, who's firing at you? And he would actually put down the SATCOM. He would sit there and he'd consciously look at his watch and he'd count out 5 minutes, 300 seconds. He'd literally count to 300. At the end of 300, he would then radio over to the forward position and say, what just happened 3 to 5 minutes ago? Right? He had situational context, he had some chronology, he had some notion of how the incident was resolved or was still resolving itself, and it wasn't this panicky San Bernardino, let's go pick up the phone, let's go change the code, oh my God, we got to do something right now, we've just tromped all over our investigation. Most of us have the privilege of not being in combatant situations, myself and Misha included, but odds are good that you're not entering this attack or this breach at time zero of the event, right? This has been going on for minutes, hours, perhaps even days or weeks or months beforehand. It is arguably more to your benefit to sit back for 15 or 20 minutes, sift through available evidence and see what else has been targeted, how often was this target visited, what collateral targets were grabbed. Is this a case where databases or database dumps or table drops were being sought, or perhaps only one specific type of binary offset or file? We see an interesting problem set in a community that we can't talk much about on the stage, that we have odd nation-state interest in our PowerPoint presentations. No kidding, they're actually stealing PowerPoint. As far as I'm concerned, every nation on the earth can have all of our PowerPoints, including this one.
Because they haven't heard of SlideShare.
But sometimes the fingerprints and signature of the attack might not be what you expect. Best not to jump on that immediately. There's a notion of non-repudiation, which comes up infrequently, but not as much as it should. This is not the notion of having perfect logs and saying, yes, we know that our network went to this at time X, this at time Y, and this at time Z, but also being able to prove, even more importantly, we know because we have comprehensive log analysis that we did not go to CNN at time W, that we were not part of this IoT distributed denial of service. We were not part of this CNN barrage. So these are things that you gain by pausing, breathing deeply, and then looking at the greater situational context. Again, assuming that you've got the log and packet trace information that we mentioned previously. Don't be afraid, your sources are not the only ones here, right? There's no reason that you can't subscribe to BugTrack, Security Focus, MITRE Common Vulnerabilities and Exposures, MITRE CVE, and other neighboring standards. Reddit's got some good stuff on day-to-day evolving attacks. Stack Overflow is rife with binary offsets and discussions. You'd be surprised, even just Googling for a spammer's user ID or email address or a commonly seen text pattern like floor, concat, rand, and the SQL injections aforementioned. It's amazing what you'll find on there. You're not alone. These attacks have been crafted across thousands of people, thousands of times, thousands of hours. And I don't know, is Minority Report a little too old-fashioned for the crew? Should we maybe go for one of these CSI shows where they take off their sunglasses and say, reply cloudy, ask again later. There should be a mentality from moment zero that you are potentially building a case file for submission into a courtroom. You may have to demonstrate that a crime is being committed right now or was not yet committed, but you had probable cause to start monitoring this individual or entity because there might be an attack 30 seconds in the future, or that you had good reason to believe that there might have been an attack 48 hours ago in which you were seeing seemingly innocent, innocuous ramifications of that now. I'll issue one final outside US regulatory warning here. If you start to collect things like IP address and browser behavior and browser agent identification and time of day and IP addresses of access, you may unwittingly be violating such EU strictures as EC 9546 or whatever EU regulation is about to supersede 9546 this year, next year. Be careful about this because you may end up violating non-American statutes in a way that you didn't intend to when you're collecting information. I know that right now we see that Amazon's own Ireland and Frankfurt, Germany zones are exploding disproportionately because I think people are so scared about this. They're putting their logs and data and servers in those EU-specific regions. It's worth thinking about. I don't know that it's worth building infrastructure there. You have to make that decision for your own business. But by overly intrusively collecting, you may actually be violating another sovereign nation, as we saw with the Facebook proceedings.
So I don't know if you guys know, but AlertLogic is headquartered in Houston. For that reason, I have good experience with building disaster recovery plans, but also using disaster recovery plans. We get flooded a non-trivial number of times, and we get hit with hurricanes fairly frequently. And one thing I've learned over the years is that every one of those plans goes out the window unless you actually play it through in a realistic enough situation and you have to respond to situations that you just didn't anticipate. And this is very much true of what happens after a breach as well. I think everybody knows and has known for a long time that you need an incident response plan and a process. My personal view is that it's got to go a bit deeper than that. I think it has to be specific enough for the environments that you actually have to protect. And there's a lot of trade-offs in those decisions. I think it would be presumptuous of me to say what is the right decision in every situation. But here's how I would think about protecting AlertLogic. Since we're essentially a software as a service provider, our production environment, the downside of letting an attacker, if we were ever to get broken into, right? The downside of letting somebody linger, right, and potentially take our services down is pretty high, right? If we're not online, chances are we're down, and if we're down, we're getting closer and closer to going out of business. That's an existential threat, and for that reason, in this particular environment, in production, I think for us it makes a lot of sense to move fairly quickly, recover as fast as we can, and really try to take the situation as it comes, right? Now, I've talked to a lot of companies that are in the content distribution business, And their playbook is even more aggressive than that, right? Because there's no sensitive data a lot of times in the systems involved in content distribution. The recovery time can be extremely fast, right? So this is where tools like KS Monkey, for example, could be, actually make sense, right? You can recover extremely fast in environments where content distribution is the primary nature of business, right? But I think my playbook for an attack against our deployment and management environment would be very different. I would be very hesitant to pull the plug on our development environment. I'd be very hesitant to make any drastic moves. In fact, in this particular case, if I saw that there was an attack not against our production environment, but against our development environment, I would want to observe what's going on for a very long time and understand who's coming after it. First of all, it's an environment that's less accessible by definition than everything else, right? So the very nature of somebody getting in there is already concerning. That's a fairly sophisticated attacker, or I would assume either that or we made a horrible mistake, right? But there's also a lot of downside in getting it wrong with that environment, right? And I'll give you a real world example where a company I think got that one wrong and is still paying the price for it. But in this case, I would want to know what exactly is the situation that I'm facing. Am I looking at a highly persistent, highly sophisticated attacker that's coming after my development environment, and what is the reason they're going through the trouble of going after my most protected assets, right? There's not a lot of I read a lot of security stories, and not a lot of them kind of move me, but this is the one that kind of sent chills down my spine. When Juniper announced that they discovered that some of their code base has been changed, they're not sure exactly when, but they had a time frame, right? They're unclear about who changed it. They're unclear about for what purpose. They're not sure exactly how they were broken into, right? I think they're going to survive, but this is an extremely dangerous situation for any company out there, right? Somebody getting into your development environment and having enough access to essentially kind of replace major sections of your code base and install backdoors into your code is a pretty big deal. Nobody does that without having a really aggressive objective in mind. In this case, I can guarantee you Juniper was wishing they had a lot more telemetry that they stored for years, not months. And I can guarantee you that even if their security team came back and said, look, we have done an exhaustive audit and we have looked at every possible scenario, we believe that at this point we've identified every bit of code that was changed, we've identified every system that was compromised. They never said exactly what was compromised, so I'm not even entirely sure that they know, right? But even if they said that, they would still be left with a lingering feeling that they missed something, right? There's no way to shake that off, and for that reason, we've seen these cases, right? I think the federal government's starting to get smarter about this. You're seeing cases where they'll announce that, look, we've had spy networks that we've been watching for a very long time. And because the impact of those spy networks, for example, these are real world spies, right, was relatively low, they were still inactive, there was a lot of downside in moving fast, and there was a lot of upside in watching them and observing them, understanding what their network looks like. The same logic applies to certain breaches that you may experience, right? So this is where I think you have to be purposeful about what you try to accomplish with what part of your environment, and make sure that everybody understands what the plan is when the proverbial excrement hits the fan, right? At that moment, that is the worst possible time for junior people to figure out what to do on their own, right? That's when you really want to make sure that you're moving with purpose and you're making decisions the right way. Right?
Nobody likes to talk about the insider threat. I think maybe we should throw out that insider threat doesn't necessarily mean a bad actor, right? It could mean a laptop compromised at home or at a Starbucks kiosk. It could be, what did we see in 2009? A Twitter admin set his privileged administrator password to happiness and resulted in a lot of financial and celebrity account disclosure. I think prudent stewardship in all of those cases, anything that you might consider insider threat, prudent stewardship dictates that no one individual or group have read-write visibility and control over all of your environments, except maybe your chief security guy, and in that case, maybe not even him. So for all but the very smallest shops, I certainly recommend that you break this into 2 or more groups. It's not enough just to break it. You're going to have to demonstrate this hard separation later on if you qualify for compliance, or worse, if you have to go through a forensic investigatory process in the absolute worst case. I've already hammered on do not share accounts, compartmentalize, give everybody individual credentials, and restrict those credentials so that one weak credential, if compromised, only has I guess we'll use the term blast radius here, such that you're not sinking your whole ship. In situations where you must share an account, perhaps you have a DevOps team or a service account that uses the same credentials unilaterally, utilize some secondary key, like have them all log into a jump box and process capture the SSH sessions or the remote desktop sessions so that you can then use that process stamp and that service account being used at the same time to say, now I know that it was Joe over at such and such office SSHing in through this shared account. That's a way to do it. That'll certainly satisfy some of the authorities. I've hammered the importance of multi-factor authentication. Even if all you can do is text messages, that's certainly better than nothing. We're running into an interesting problem with offshoring and globalization where sometimes your developing nation workforce doesn't have corporate cell phones that they're willing or able to bring to the enterprise, in which case you're back to 99-cent Okta tokens or Duo tokens or push technology of similar manufacture. Get into the habit of either you or some trusted third party parsing through your logs every day, each and every day, looking for anomalous signatures, patterns that recur, perhaps even if your environment is too large to fully comprehend day for day granularly. Get used to things like traffic baselines that go more than one standard deviation outside the normal volume that you see for that day, or anomalously long queries, 512 bytes, 1024 bytes, 1024. 2048, things that you wouldn't normally see submitted into a web application. And as I say, I like to look at user creations, API invocations, and then privilege add removal edits. I contend, we keep saying the same thing, a lot of this work is going to be learning the normal for your enterprise and learning the new normal and understanding if that shifts. If Misha starts logging in on CloudTrail with a Lenovo one day instead of his traditional Mac using Firefox, I want to know why that's true. I want to know why that change happened and if that is truly innocuous. That's going to involve some coalescence of top talkers, typical activity patterns, typical volumes, typical time of day. You may be able to do this stuff by shifts. We have an anomaly that surfaces every once in a while, plus or minus a day, and I can reliably reproduce it about the 28th, 29th, 30th day of the month. And some of you are already figuring out that's a trusted third-party PCI DSS validation scan that's run by some financial group that I'm not in close contact with, right? Good to be able to see that sort of thing and predict it when it happens.
So we're going to start to wrap this up. I think we have just a few more slides left, but I think you have to kind of set a set of ground rules for yourself. And one of the first is you should assume that at some point you'll be breached. There is an unnatural amount of shame that's attached to the notion that some of us might get compromised. I think that the number of people that admit to ever being compromised is lower than it probably is in the real world. And I never fault anybody from getting broken into. I think any environment can be breached. I do pass judgment on people that are in denial about it or respond poorly. I think we're measured by how we respond to those situations. But the complexity of the attacks we're seeing out there is so high that I assume that if somebody really wants to go after you, they'll find a way. You got to be ready for it, right? And I think it's healthy to build your plan with that in mind, right? You should always assume that that you should make copies as much as you can, to the extent to which is practical. And this is the great thing about AWS, kind of replacing an instance is not unnatural. That doesn't mean that somebody is doing something forensically, right? That just means instances get restarted all the time, right? So snapshotting data makes a lot of sense, right? Your log data hopefully should be in some place that attackers don't have access to, right? Don't allow your forensic repository be controlled by the same set of identity keys as the rest of your environment, right? You have to somehow operate. Let's take that worst case scenario that your development environment is getting targeted because there is an extremely sophisticated adversary. You have to somehow observe them without tipping off the fact that you're watching. That's not easy to do. That's hard to do, and this is where if you don't have visibility up front, installing a whole bunch of security tools after the breach is a dead giveaway that you know something's going on, right? So you should really think about that ahead of time. This is one of those things where it's got to look as normal as possible, right? And finally, kind of use the best elements of cloud to your advantage, right? There's a lot of avenues by which, security people have always complained that we've had zero control and we never had enough say in how architecture is done. The tooling has been kind of horrendous. kind of the baseline functionality that's built into cloud platforms these days is pretty fantastic, right? The level of visibility we get with CloudTrail is not something we've seen before. Even with VMware, right? Those same messages can be found in VMware logs, but good luck trying to trace them, right? Every product seems to have a different set of IDs, and it's not easy to go figure out what's going on. I've really been enjoying watching how every cloud provider out there evolves their logging stacks, and I think there's more and more work to be done there. They're making our jobs at AlertLogic a lot easier these days, right? So use kind of cloud environments as a tactical weapon, right? There is a lot of capabilities that most people underutilize in cloud environments, and there's no reason to ignore them.
I'll go even more philosophical. Misha likes to talk about blast zone and blast radius. I think there's some philosophical risk acceptance here. You only have so much energy to put shields around the enterprise, right? You only have so many brain cells to think of new attacks and to block attacks. You only have so many resources and staff and people looking at logs and packet captures to successfully protect against these sorts of compromises. You can't stop it all. Somebody will get one past the goalie eventually. So I propose that we take this bleak, we're all going to die, we're all going to get hacked mindset and turn it into, here's the 68% of attacks that I know about, trivial denial of services, buffer overflows, SQL injections, things of that nature, and here are ways that I know how to defend against those. If I have resources and budget and wherewithal and time to think about a thoughtful architecture, these are the things I can attack. I maybe have another second deviation out here, maybe another 20, 30% of attacks that I could conceive of if I had a little more time, a little more wherewithal, perhaps if I had 4 more analysts on my team, if I had additional budget to instrument and to put sensors out in the grid. There are things out in the 1, 1.5, 2, 3% tails right on the end of my environment that I will never ever think of. Or if I could think of them, maybe it's infeasible to the point of impossible for me to block or prevent them. So the story here shifts from I guarantee we'll never get hacked to, oh my God, we're going to get hacked tomorrow, to we've layered these meaningful, thoughtful defenses, and what gets through is part of our rational risk response as human beings. This will drive this pyramid, no Scientology jokes, this pyramid of compartmentalize. I've said it over and over again, it works just as well for a submarine, for a web infrastructure, for a zombie apocalypse. Put everything into easily isolated blast containers to the degree that you can. Instrument your enterprise effectively with known granular thorough logging, with packet capture if those capabilities are within your grasp, with user behavioral analysis, knowing that Misha always logs in from Safari or Firefox using his shiny new MacBook with 6 dongles sticking out the side of it. Maintain your evidentiary chain of custody logs and be very thoughtful as you do this, that you're not just keeping logs to look at later, and you're sure as hell not pulling logs the day of the compromise. You're keeping 12 plus months of logged data that is cryptographically stamped as this was secure, this was put in a court-suitable Ziploc baggie such that if some third-party auditor or investigator comes in, he or she will be able to attest that, that this is inviolate and this is trustworthy, this was not manipulated or deformed because it is as it was when it was first collected via hash stamp, encryption key, what have you. And then the top level, this is really where Misha was going with using the cloud environment tactically. There's no reason that you couldn't keep additional copies or replicas or real-time fault-tolerant duplicates of your computing environment, your process, your storage, your S3 buckets into areas that maybe no user can see. Maybe you have an entirely, I think Amazon likes the blue-green methodology of load balancing and failover. Why not go blue, green, purple? And maybe purple lives off to one side in a cheap 0.4 of a cent per gig per month Glacier repository. And that backup gets only touched in the event of break glass in emergency and both of our zones are compromised and we need to flush and start over. No reason not to do it. Lastly, this is the fire drill point reemphasized. Sometimes a yearly or a semi-annual fire drill is useful. Not to the point where you're spreading fear, uncertainty, and doubt by saying, oh, the sky's falling, but I'll pick certain things like a suspicious quick brown fox jumps over the lazy dog SQL injection attempt, or maybe a suspicious Jenkins push, Jenkins promotion at odd hours of the evening, and I'll follow that to ground. I do that for 2 reasons. One is that I may not myself understand the syntax being used. The second is I want my trusted admins and my trusted engineering teams to be able to show me, yes, we know what that was, or no, we don't right now know where it is, but we know where to look. It's okay to miss something, and it's okay not to find it the first time. It's not okay to never have looked, and it's not okay to not know where to look, right? I think that many of the people in this room would find if you went and did an incident fire drill, you'd end up with somebody going, sorry man, we only keep DHCP logs for 72 hours, we don't know who used that address. Sorry, that Apache server stopped logging its syslog daemon broke 6 months ago and nobody ever looked at it, so we actually don't have good data for the last 2 fiscal quarters, right? That's embarrassingly common, and that's part of what sunk Sony Pictures in the 2014 Amy Pascal situation, not good. So one of the things you can do here, rather than just spook everybody into some Richard Nixonian, we're all gonna die paranoia, is to raise stakeholder awareness, stakeholder buy-in, and say, I'm reliant upon you, DevOps, engineering, finance, marketing, to give me some of the information and the chain of custody I need. You are all my junior security engineers. You are all my distributed security sensors, right? That gets really, really important. And frankly, if as security officers we're not communicating and promulgating our message out to the masses, we're not doing a good job. Nobody benefits in the end.
And I think one of the important things to get right is getting the roles right? And this is, I'm actually curious how you think about it. In a incident response scenario, who's got the ultimate authority? Is it the CEO or is it the chief security officer as somebody who owns the incident response, right?
Yeah, excellent
Who can
question.
issue the shutdown order, right?
I see these, so an incident response cycle, like the one being questioned, typically goes in 2 or 3 feedback loops. There's an incident coordinator, which is me or Misha or somebody like us, and that person rings the bell and says something very bad has happened, I'm not sure what it is, and now I escalate to principal DevOps, if it's what I think is a level 1 situation, to VP of engineering, if I think it's level 2, to board and legal counsel, if it's level 3. And I'm probably gonna wait, unless I'm really acting out on a limb and saying, no, we need to shut this off for the good of the country. I think we wait for that feedback loop to complete. But I see a lot of incident response plans and ultimate responsibilities boil down that way.
This is a common question we get in the SOC. Our job is primarily triage, right? We can't possibly make a decision about whether we should shut anything down in your environment. So there's a lot of confusion that happens when we escalate the breach to somebody. They usually ask us, what should we do next? Should we shut things down? And that's not a good question to ask your triage party, right? Our job is to make sure that the incident gets to the right person and somebody who understands the business actually can act in it the right way, but there's always a lot of confusion about who exactly is that, right? Who has the ball in this scenario? So that should be part of the incident response plan.
Even though that judgment call is not often the third-party SOC or the first-party threat coordinator guy, you/they should always know that question is immediately forthcoming. So this is part of that building a legal case file and saying, sir, ma'am, I've compiled this data that suggests this happened at this time. I think this means that you might have a compromise here. The decision is yours. I think that you might want to consider 2 or 3 different courses of action. And that can be reproduced in almost every incident conceivable, including all the ones we've talked about here today. The good news is that you don't get to choose whether you do this stuff, you just get to choose when. Because if you didn't do any of the log analysis or sensor instrumentation beforehand, you're sure as hell going to do it when an underwriter or an insurer or an auditor comes in and investigates you later.
Guys, thank you very much. Sven has way too many slides and I didn't see anybody fall asleep. So we really appreciate it. We'll be here for a couple of minutes if anybody has any questions. Also, we have a big orange booth on the show floor, so I'll be there at the reception time. If you're around, would love to talk to you.
Thank you all. Thank you again.